Total Seal, Lake Speed Junior Tribologist. Ed Kiebler, how you doing? It's great to see you again as well.
I'm doing well, Brad. And you?
Oh, fantastic. It's actually, I know, weather around the country is doing all kinds of crazy things. I'm here in North Texas today, and it's literally a beautiful spring day. So, or fall day, I guess it would be this time of year. But yeah, so we'll see how it goes. But anyway, welcome, gentlemen, and Lake. First of all, I know you've been on here a bunch, which has been great, but you are a tribologist. Explain to someone who might not know exactly what that is.
Fair enough. So funny enough, Brad, you asked me that question, and I'm in basically the pinnacle of tribology right now. So tribology is the study of friction, wear, and lubrication. And I'm actually in San Antonio, Texas right now at Southwest Research Institute in the tribology lab, actually right now, coming to you live. In Southwest Research, if people don't know, is the largest independent research lab on the planet. And they do way more here than just tribology. I think I saw a sign when I was driving in yesterday that said from deep sea to deep space. If it's something in the physical universe, from bio to nuclear to whatever in between, these people here can research it and give you fundamental research to make better decisions so that you can go further. This is an absolutely amazing place. I'm in nerd heaven right now.
Wow. All right. That's awesome. So we're about 5 hours away from each other, which is great. Ed, are you up in Washington, or where are you?
No, Brad, I'm actually in the middle of the country in a little place called Cedar Hill, Missouri. So we also have a nice sunny spring day right now, or fall day, I guess you'd say.
Very nice. Awesome. And Keith, welcome. Appreciate that. Where are you? Are you in North Carolina? Where are you today?
No, I'm in the real South, the Southwest. I'm in Phoenix, Arizona.
Awesome. Well, so fantastic.
It's a 70-degree day. Actually, I think we're supposed to be like 67. So we're having our version of winter right now. For all those folks out there that have gotten a little snow already. It's a beautiful day in Phoenix.
Yeah, well, we'll just make everybody jealous. All right, so Lake, I'm going to let you start it off. Just give us an overview. We talk about so many different things with you. What are we talking about today here with Total Seal?
So we're going to talk about how you can actually change how you hone the block of your engine to make more horsepower. And we can really get to the real simple answer, but that's boring. We want to have the fun part of explaining how you get there and why and the science behind it. Because when you understand how something works, then you can replicate it and you can tune it to your environment to be able to make it, as opposed to just having the recipe for one application. So we want to do today is really get into the science behind why honing can impact the amount of horsepower your engine makes and greatly improve it. Is the actually long-term goal, because we all know we've been honing engines for way over 100 years, right, Ed?
Yes,
I think the Sun guys have been around for how long they've been in business, and Rottler's been in business almost 100 years, right?
100 years next year.
So
wow.
They've been honing engines for over 100 years, and they all run. But the reality is we can make more. We can keep getting better, and we can apply some science to this to be able to get better. Brad, can I actually show a video real quick?
Yeah, I believe you can.
All right, I'm going to try sharing my screen, and I'm going to play a little video of some of the testing that we're doing together between Total Seal and Rottler and Southwest Research right here in this very lab. So I'm going to hit share. Hopefully you guys can see it. I'm going to hit play. Can you guys hear me?
Yes.
Yep.
All right. So what you're seeing is a piece of cylinder being rubbed with a piece of ring against it. And then you can see that's the use piece. And we measure that use piece using the software from digital metrology. Can take a profilometer trace so that you can see the worn and unworn section of the ring and liner. So you're seeing right there, that's the worn part on the far right, and that's the unworn part as honed on the left. So kind of neat stuff that we're able to do here. And I'll come back to me wherever I am. Oh, me, I gotta stop sharing. There we go. There we go. Now I'm back, right?
Mhm.
I have no idea what I'm doing technology-wise, so just bear with me.
Hey, look
Oh,
like
no,
you're
that's
all right to me.
yeah,
So
I think
anyway, that's the neat part is, I mean, literally, we can take a cylinder, and actually Ed honed these cylinders last Monday, right? He
Yep.
honed one of them Monday, shipped it down here, and these guys cut it up. They were taking a big cylinder and they section it into a piece just like this. And this is one of the worn pieces. And you can see that little black spot in the middle is where the ring has been running against the cylinder. So we can take real rings, we can take real cylinders, and we can simulate what happens in the engine on the tribometer back there. And then we can take all these really amazing tools like the profilometer, like this optical microscope right here, and then we can characterize that surface before it's run and then after it's run. And of course, the tribometer back there can actually measure the running friction. So from ring coatings, how we hone the block, oils, the additives, the viscosity, we can do all of that and know what the friction is and what the wear is. And just to throw another wrinkle in there, you would think that friction and wear are related, i.e. that if I reduce friction, therefore I would reduce wear. That sound logical, guys?
Mhm.
What we think?
Definitely.
100% not the fact.
Wrong.
Wrong, wrong. They are two independent phenomenon. We can increase friction and decrease wear, and vice versa. Or we can increase friction and increase wear, or decrease friction, decrease wear. They're completely independent. And we've seen that already in the last couple of days, just doing testing here. The results can be all over the map. So that's why the science of this is amazingly cool, so much fun. That's why I said I'm in nerd heaven right now. And the reality is for the viewers, okay, what does this mean to me? What do I get out of it? I see that Lake's having a great time, fantastic. But what does this do for me? And for my race program, how do I get better? Well, the reality is we can point you down that direction because of the fundamental research we're doing here. We can tell you for a fact that a PVD coated ring, so PVD, for people that don't know, is just an abbreviation for physical vapor deposition. So it's a process for applying a coating to really to any part, right? I mean, so there's been DLC coated lifters, there are PVD coatings on valves. I mean, so PVD type applied coatings are very common in the racing industry, from I said valves to cam followers to wrist pins. We've been doing it. I mean, Keith, how long we've been doing that to piston rings? But probably 20 years now, at least.
Early 2000s.
Yeah, so 20 years.
Around, kind of 2000, 2001, started playing with PVDs. We needed to find something, we talk about, the molybdenum coatings, the chrome coatings that have been around forever. And, we'll just say their shortcomings compared to what we have today, and started looking.
Well, why don't you explain, Keith, explain what the difference between chrome, which we've all heard of chrome rings and things like that, and a moly ring. And I'm going to steal your thunder, Keith, because you've told me this a billion times and I hear it frequently. No one has ever used a chrome moly ring. It does not exist.
Exactly.
Chrome moly is for BMX bikes. That's bike tubing, right?
Absolutely. This is pipe. This is bike tubing, roll cages, things like that.
Yeah, my mongoose bike I had when I was 16, that was chrome moly.
Yeah.
That's
my
piston rings are not.
On there said 4130. Yeah.
Yeah, exactly. So that's tubing. That's different. So explain how a PVD type coating is different than chrome, or from the moly, plasma moly coatings that people might be familiar with.
Well, yeah, the coatings that, we'll go back historically, chrome would have come first. I mean, initially would have been no coating, just plain material, plain, cast iron. Doesn't wear very well, doesn't last very long. Back in the old days, and we'll go back way to the old days, you got 5,000 or 6,000 miles of it. We were doing pretty good. Everything just wore out.
Yeah.
But, chrome came along, but the chrome we're talking about is an electrofusion chrome, just like your plate and the bumper on your 57 Chevy. I mean, it's that exact same process. We're going to take it, we're going to dip it. You're going to have this neat hard coating, but it's lumpy, bumpy. The thickness can vary 3-4 thousandths all the way around the diameter of the part. So it's really not technically a really nice coating. Granted, that's part of why chrome has such a kind of a bad rap. Oh, it takes forever to seat up. It burns oil. It does all these things. Well, it's not the chrome itself. It's the inconsistency and the thickness of the chrome,
Bingo.
the hardness of the chrome. It's the we'll say not being processed after plated. So time moves on, and we get into molybdenum. I'll bet it. So neat coating. It's got some real interesting properties. One of those being it's very oleophilic. It holds oil like a sponge. It's up to about 40% porosity. So, imagine a coating on your ring that stick it in the oil, and guess what? It's full of oil. It gives you a lot of room to not get your surface finishes right. It's that Band-Aid or that backup to not getting your wall finishes correct. Been around forever. Problem with the coating, one, it's becoming more and more expensive, but mainly it's always had adhesion problems. Molybdenum does not stick well to the ring. So again, everyday driver, everyday application, 9-to-1 compression, detonation's not a problem. Hey, it's going to probably be okay. We throw that coating into something that's got a double 500 shot on it, or 30-pound of boost, or copious amounts of alcohol going through it. That coating's not going to be sticking around for very long. It's going to go the way of the dodo. It's going to come off the ring. And, worst case, now it's going to get stuck in the skirt of the piston. It's going to tear everything up and create a disaster. So, in the right place, molybdenum is okay, but generally speaking, in a performance application, it's really not your friend. It's just looking to leave the do exit stage left and just give it a reason, and it's going to be gone. PVDs, physical vapor deposition coatings, these are applied in a vacuum chamber. These are going in positive and negatives. We're going to have, you hear the word chrome nitride. If you've ever used a stainless steel valve, it's chrome nitride coated, but that's not chromium. That's not a hard chrome. It is material that is ionized. It's in the vacuum chamber. It's attracted positive and negative. They literally come together on the molecular level. Can I take that coating and take it to a bench grinder and grind through it and get it off? Yeah, sure you can. Is it going to flake? Is it going to chip? Nope. Not unless there's, not unless there was some kind of contamination when it was applied. Could it possibly have an adhesion issue? Yeah, but it's really pretty rare. You don't see it very often. So generally speaking, the PVDs, we've got a nice range of coatings that range from, we'll say, the low end of the scale, tungsten carbide carbon, which has very similar characteristics as far as friction goes compared to molybdenum, then into the chrome nitrides, titanium nitrides, DLCs, and even some hybrid coatings where we're kind of putting multiple layer coatings. We'll say soft on the outside, hard on the inside. Trying to get,
we ran one of those this morning. Shh, don't tell anybody.
So
we may have run one of those today.
Yeah.
Maybe. I don't know. I will neither confirm nor deny the fun things we've been doing today.
Like any performance manufacturer out there, we are constantly testing. This is part of why Lake is at Southwest. We're always testing. We're always looking for the next, that next thing. What's the next thing? Because we got PRI coming up next week. We've got EPARTRADE show. We've got all these. And what's the one thing these people never ask you? They never ask you for less. What's new? What can I do to make more power? Even if they can't use it.
Give me that old stuff. And it doesn't work.
Horsepower more than you need. No, I need more. I need more. So we're constantly driven to find that next thing.
Thanks, Keith. That was a great explanation of what the difference in the coatings were, because like I said, that's why we're here, is to keep pushing the boundaries and find more so that you can unlock a little more power. But of course, when you mentioned on the coatings and the porosity or the lack of porosity, the one thing we can say for a fact from what we've seen from the testing here, and we've seen it in real world too, is that when you apply that PVD coating to the face of that ring, it lowers the friction, and most importantly, it lowers the wear on the ring. That when we ran uncoated rings versus the coated, PVD coated rings, we saw a pretty dramatic difference in the amount of wear measured on the surface. Because one of the things we can do, and I reach it back here and I'll grab it, is when you run that little tribometer over there, you're running it in the bath of the oil. Well, guess what? we can analyze this used oil, and then we can see how much wear debris is in the oil. So it's a great way of characterizing how much wear occurred during that test, because it's a fixed volume of oil running at a fixed load, fixed speed, fixed temperature. We can measure that, we can tell. And so we were seeing upwards of 80 to 120 parts per million of iron, that's just wear from the cylinder, when on the uncoated ring. And like you mentioned, Keith, the chromium nitride coating on the ring, well, that if it was wearing off and chunking and flaking, we would see that in the oil as chromium. Well, guess what? On all the tests we ran, 0 chromium in the oil. So the coating's staying in place. The coating's really not even wearing at all, but that cylinder is wearing in. And you can see the difference that that uncoated ring, that gas nitrided ring with no coating, was kicking up anywhere from 80 to 120 parts per million of iron. But then when you go to the coated ring, we were down less than 50 parts per million. And then when you change the oil and you go from just a regular passenger car oil that's going to have a higher level of detergent, lower level of ZDP, and you go to a proper break-in oil that has basically very little detergent, no friction modifiers, and a higher level of ZDP, that wear dropped even more. Now, the friction will go up with break-in oil because break-in oil doesn't have those friction modifiers. So it's not low friction, but it's low wear, back to what I mentioned at the top of the show. They're independent phenomenon. But we were able to get the wear from a high of 120 with, we'll call it the wrong oil and no coatings on the ring, down to 20 parts per million with the right coating and the right oil chemistry. So pretty stinking cool. Oh yeah, by the way, we changed the surface finish in there. So Ed, why don't you tell them a little bit about the different surface finishes that we've been testing and how we went about achieving those?
Yeah, so
Ed, do me a favor. I just wanted to touch on one thing that Lake
go
brought
ahead,
up. And I
Keith.
just wanted
Sure.
to just throw this out there real quick. You had mentioned the gas nitride ring, and there's a lot
Yep.
of companies out there that sell gas nitride rings. And I just wanted to put this out just to be clear. Gas nitriding is a surface hardening process. It is not a wear coating.
Oh, good point. Yeah, I failed to mention that, Keith. That's right. Gas nitriding is not a coating. So when I said we ran an uncoated ring, I meant we ran a gas nitrided ring. That was the baseline ring.
Because there are some people that when they hear that, they share the word nitride. So, oh, well, it's coated. And I go, no, it's not. It's
No, the gas nitrided ring,
your crankshaft.
Uncoated. Right.
And sorry, I didn't mean to cut in on you.
no, you're good. Listen, every time I'm in one of these things, I learn something from you guys. So I enjoy just sitting and listening. But to get to surface finishes with Lake and Keith's help, we've been experimenting with different surface finishes, and I think the three of us have kind of labeled the new finish as an extreme plateau. What we're looking for is we're looking for that fine finish that the ring will ride on, and we're looking for what we call the core roughness, the RK values that will support that ring and not wear. And then we're looking for the RVK numbers, or the deep valleys that the oil will ride in. And people say, well, I've been honing this way for 30 years and I didn't need any of that, and and my motors run fine. And we're not saying you're doing it wrong. What we're trying to explain here is there is a better way to do it now. And we believe you'll see horsepower gains and performance gains.
I'm going to hold this to the camera while you're talking, Ed.
Yeah.
That's what it looks like.
Yep. Perfect example of what we call an extreme plateau. And I was just on a forum this past week, and it's like, oh man, I've been doing it this way for 50 years and it works. And yep, it does work. But they go to a 220 grid and then they leave 3/1000ths, and they go to a 280 grid and they leave 1/1000ths, and they go to a 400 grid and they leave a couple of tenths, and then they go to a 600 grid. When you do that, you're not plateauing the surface. You're simply changing the surface finish from a rough finish to a fine finish. The rings love it initially, but
Mhm.
there's no oil retention. And so you don't have near the sealing properties that you would with a higher RVK number, and you'll have greater wear properties as there's no oil up there on the cylinder wall. So to get that, we've kind of backtracked and we've gone to a very rough abrasive, and it will depend on what your applications are. And that's where Keith and Lake come in. I tell people all the time, I'm not smart enough to tell you what finish you need. I'm just smart enough to tell you how to get it. And so, one of the things we've done at Rottler is, and again, with Keith and Lake's help, is we've started experimenting with rougher and rougher abrasives. And it used to be, you had a 80 grit, or you had a 140 grit, or you had a 170 grit. Rottler now has the ability to have, we have a 70 grit, an 80 grit, a 100 grit, a 120 grit, a 140 grit, a 170 grit, because we're finding in different applications, you may need more RVK. And again, depending on the Brunel of the block, and Keith will get into some of that a little bit later, but we put that base rough finish on there, and then we simply just count strokes. With our machine, we have the ability to feed the stones out without spinning at the top of the cylinder, which is super important when you're trying to do these plateau finishes. And we literally feed the pressure and then stroke for 6, 7, maybe 10 strokes. And that gives us that plateau, or that smooth finish for our rings, but we maintain our deep RVK numbers.
So basically, it's the valleys are still there, but you smoothed out the peaks.
Absolutely. Perfect analogy, Brad. Yep.
Yeah. Looks just like this.
Yeah.
Smooth on top, but you've got those little fingers going down. All those little fingers are the valleys. That's what holds the oil to both lubricate the ring and to provide the seal, because oil is the gasket between the piston ring and the piston and the cylinder wall. If anyone's ever leaked down an engine dry, they'll know that if you put a little bit of oil in there, all of a sudden that leak will change big time. Or cranking compression test. Put a little bit of oil in the cylinder and that will bump that cranking compression up. Why? Oil is the gasket between all those parts. So it's not just lubricating it, it's also sealing it, which is why, back to what Ed was saying, is why we have to have all these different abrasives for different applications, is because you can go from anything from just regular old gasoline, with a 14.7 to 1, stoichiometric air fuel ratio, down to a top fuel car that's methanol, which, God, I don't know, it's like 4 or 5 to 1, right? It's stupid. I don't know what the exact number is, but they put so much methanol, or in nitromethane, I should say, into a top fuel engine. There's so much fuel wash that the poor oil stands no chance. You got to have more valley to hold more oil. And that's really the rule of thumb here, Brad, is that the more fuel you put through the engine, the deeper the valley needs to be to hold the oil to resist the fuel wash, because that oil is going to try to be washed away by the fuel. And the more solvent the fuel is, so, methanol, man, it's going to come in there. It's going to try to knock all that oil off the cylinder wall. Well, what happens when it does that? It's going to hurt you on blow by, because you're losing some of your seal, but you're also going to see increased cylinder bore wear. And that's why changing these abrasives and to get the correct amount of valley for what you're doing is so critically important in order to really unlock that hidden horsepower. And Ed, give them some examples. I know you've heard from a lot of customers what kind of power gains people have seen making these changes.
Yeah, it's pretty amazing. I set a number of these machines up, and we've seen anywhere from a low of 8 horsepower on a dirt modified motor up to 20 horsepower on a blown alcohol motor. It's pretty amazing. I mean, fellas that aren't really looking for horsepower, they're just looking for an easier way to hone and a more consistent way to hone. And you go back a week later or a month later, and you just ask them, say, what'd you see on the dyno? And to a man, every one of them's telling me the same thing. Geez, oh Pete, we found some horsepower here. We never expected that. We just were looking for a better way and a more consistent way to hone our cylinders.
Well, then beyond the we'll call it the free horsepower from doing this, Keith, why don't you share some of the experiences the engine builders have had with increased durability. Because that's one thing, you know, Brad, that's the common trend right now in our industry is that the sanctioning bodies are coming up with rules and stuff where the engines have to live longer. You're not able to run an engine one race and then rebuild it anymore in a lot of series. You have to run multiple races or even a whole season now in some cases. So the added durability, Keith, why don't you talk to that and share some of these testimonials people have had? Because that to me is almost the most mind-blowing part.
Yeah, it really is. I mean, a lot of what we're talking about today is, you know, we'll say derived from this need to seal it up better and last longer. You know, if it's got to go out and it's a one and done, maybe you can get away with a lot of stuff. But if it's got to go out and you want to get a full season out of it, typical conversation I would have, say 5 years ago, 6 years ago, circle track guy with a ductile Molly 043 ring pack in his circle track car. And, you know, that mid-season rebuild, man, she's, you know, I got 10 shows on her. She's huffing and puffing and, you know, re-ringed it and boy, it's right back where it was. Well, the honest truth of that wasn't the ring that did it. It was the re-honing of the block. It wasn't the ring that was gone. It was the cylinder finish that was gone. It was too smooth to begin with. More than likely, you know, maybe a little too much fuel, a little too much dirt. So working on these bore finishes, getting these deep valleys, getting this extreme plateau, we're just finding that extension and longevity. Because as Lake said, and as Ed knows, oil is the gasket. This is the lubricating factor, not only just for rings. I've had, you know, pulling tractor guys, blown alcohol guys, nitro guys suffering from a phenomenon we'll call black death. You get that piston out, the skirt's just wiped out. It's history. Well, that is because of the fuel load. That has got so much fuel going through that engine. We're killing the oil film. We've turned it into solvent. So getting that bore finish corrected not only improved that ring seal, we got the longevity back out of it. Guess what? It stopped scuffing skirts. You know, they're having the piston company do this and change the cam, change the barrel, do all these things. It's simply a lack of lubrication. Once they corrected that bore finish, they got that really deep valley to get that oil trapping. Because remember, folks, the rings are doing their job. Their job is to scrape all the oil back into the pan. You know, we're throwing copious amounts of oil up there. We've got big pumps and loose clearances and throwing all this up there. Well, if it doesn't have something to grab onto, that rung on the ladder, that RVK, that depth, that oil is going straight back into the pan. The rings are going to scrape it back down, get rid of it, and the parts are going to go dry, you know, essentially dry. And we're going to lose that oh so important ring seal. And once that ring seal starts to go away, what do you have? You've got blow-by. That blow-by is going down the cylinder. And what oil is left? It's pushing it back down to the pan. It's vaporizing it. I'll have customers send me rings to look at. The second rings are budded. Well, I have a bigger second ring gap. Why did you do that? Because you lost the ring seal on the top ring. That superheated combustion gas is now getting past the top ring. It's going down the cylinder. It's overheating the second ring. It's overheating the oil below the top ring and creating all kinds of negative effects in the engine, which all lead to premature wear and premature engine failure. So getting this valley, it's so important. And it's like, you know, Lake said, you know, testimonials, you know, particular customer of mine in Wisconsin, and we all worked on this guy together, from oils to bore finishes to rings, you know, pulling tractors, you know, 4,000 horsepower, 300 pounds of boost, built everything out of unobtainium as far as the parts and the coatings went, made no difference. Lake built, you know, their version, this is prior to him working here, his previous, we'll say, life as the you know, the lubrication specialist.
Oil guy.
Custom building oils. You know, everything we did made a little bit of difference, but nothing significant. The one thing that made the difference was getting that RVK up. We started going into territories that at the time I never thought any engine would need. But the higher we got that valley, it just kept getting better and better and better, to the point that we ended up in the 150 plus range on the valleys. And guess what? Now we've got engines that dyno just great. They've got no pan pressure. Look at that. This thing went from an engine knocking the valve covers off to it's only got 3/4 of a pound of pan pressure on diesel and no issues, all simply the RVK. And I can tell this story over and over and over. You know, Lake had some show and tell stuff.
Yeah, I know of at least what 3 other guys who are diesel guys have all had the exact same story. I mean, Ed, you got me looked up with the guy, Drew.
D&J.
At D&J, he did the Engine Performance Expo thing with us last year. His story was he couldn't get an engine off the dyno, right?
Right.
To then he's running the full season on the same engine without ever rebuilding. The only change was the RVK. Same pistons, same ring, same oil. The only change was the surface finish.
we got a great testimonial earlier this year. We like to do as much of these as we can, but we also, we do, we'll say going back out on the road's a thing again. This is, this is great. Did an AERA technical conference at Wagler's in Indiana. It was great. And I got to thank him again, Jeremy. When we closed the show, he brought 2 pistons out, and one piston was from the prior year. And he complimented us and thanked myself. He said, "This is what I had last year. I was going out of business. This is what I have this year. Absolute perfection. Simply that change in the cylinder finish. Didn't change the rings, didn't change anything else, just changed how we're honing the blocks." And same thing, went from an engine you couldn't get off the dyno to, hey, this has been running all season. It really does make that difference.
So when it comes to the longevity, I mean, are realistically, are we saying you can go twice as long, you can go further than that, 50% longer? What does it do to that?
I've seen engines, I can't, say to every application, but I've seen, we'll say road race and circle track type applications that would go through 2-3 rebuilds a year. And, our owner, Matt's going to hate it, but, hey, they're going all season now. So they're buying less rings, which is kind of a problem. But you know what? We got their board finish straightened out and they're going all year and not having to touch it.
That's incredible. It is, and in just changing this process. Now, how do you know, you talk about ring coatings and different things like that. And obviously you're doing a lot of research where you are, Lake. How do you know
I was
what to
trying to find a
match?
dyno sheet on my phone for a customer. I'm sorry.
That's okay.
Yeah, it was long story short, first time this guy had a normally aspirated small block go over 1,000 horsepower, just changing the board finish. Only thing he did different. I was trying to find it, but more digging.
Yeah.
And it picked up vacuum because it had a better ring seal.
Yeah.
That's incredible. So when it comes to matching the rings and doing what you need to do, how do you find out how deep your valleys need to be, the right rings to use, all of those different things?
Well, I'll say this, and Keith mentioned it earlier, that obviously the old school ductile moly rings are still out there. They are lower priced. A lot of people have used them with success because they're forgiving with the bore finish, because of that porosity. But the reality is they should not be in any competition engine, period. If you're really serious about getting better and going faster and making your engines live longer, you need to get away from iron rings. You need to get into a steel ring. And then, as we've already mentioned and proven, that needs to be a PVD coated steel ring, not a gas nitrided ring. The coatings are going to give you a better protection, better durability. That's the real gain there, is going with the coated ring. So that almost in a sense takes care of what the ring choice should be. Now, the thickness of the ring, a lot of that is going to depend upon the application. Sometimes there's rules that specify what the ring size has to be. Well, then you're stuck unless you want to cheat and put use spacers. Then you can call us. We can help you with that. There's ways around rule makers,
We love the gray area.
We do. We can do things like gas porting the rings. You can't gas port your pistons. We got cool tricks for those who are creative rules interpreters. We feel you. We're with you. We'll help you out with that. But if you have the freedom to use whatever size ring you want, essentially, and Keith may correct me on this, you want to run the thinnest ring you possibly can, that the heat of their engine doesn't kill it for your intended length of application. That's what you want to do. I mean, I go back, we may have mentioned this in the previous webinars before, but you go back 20 years ago, 2002 in NASCAR, an 043 3mm ring was the state of the art. That's what most people ran. And it lasted one race, and those engines will be down anywhere from 5 to 8 horsepower. Today, those guys are running 0.5, 0.6mm rings. That's half the thickness of the 043s. And they live 3 times longer.
Wow. So Ed, is this something proprietary to Rottler, or, explain the process? And if I'm talking to my engine builder saying, hey, we need to look into this, what's the best way to go?
Sure. No, it's not proprietary to Rottler. We've just worked hard with the fellows there at Total Seal to kind of develop this process. But we'll tell anybody how to get there. I mean, I'm more than happy to talk to a customer that has a competitive hone and explain to him what I think is the best way to try to achieve those. This is we're just trying to help the industry and help guys go faster and make more horsepower. Honestly, it's now we have some features on our hone that again, when you're talking about these extreme plateaus, we have the ability to expand those abrasives, the 600 grit abrasives, without spinning the hone head. That is super important because, as Keith and Lake will attest, 1 or 2 strokes more or less can make a whole lot of difference when it comes to RVK. So it's a much more concise, more precision honing than we're used to. It used to be, a guy had grabbed the hand wheel up there and he'd kind of feather it and he'd make a stroke and then he'd back it off and he'd pull it a little bit more. The new machines really take the operator out of it. It's all about consistency. It's all about, you build 6 motors and all 6 of them come out with the same surface finish and the same roundness and all are within a couple of horsepower of each other, hopefully.
That's pretty incredible.
Yeah, I think what Ed's saying is spot on, and I've seen him do it, by the way. That's just not a pitch. I mean, if you've got an old CK10 or CV616, I've seen Ed talk to guys and say, hey, you need to use this abrasive. Here's the process you need to do. And same thing for us. I mean, we're not, we want you to get the right surface finish. That's the ultimate goal, because the ring doesn't know if it came from a Sonnen or a Rottler or Bubba's dingle ball hone in the backyard. He does. The ring doesn't know. The ring doesn't care.
Right.
All it knows is the surface finish. Is it the right surface finish for the application? That's all it knows. So we want to get people get the right surface finish. And what Rottler really does well is that their machining technology, because of how Ed said, is consistent, is very user friendly. It saves you time. You can literally, with some of the machines, put the block in, do a couple of locating, put some inputs in, and push a button and walk away and go do something else. So for a small shop, it's actually the best thing you can buy because it frees up your time. You're not sitting in there doing this the whole time. You can go do something else while the machine's getting the block done and getting it done right. And it's that consistency. But one thing we need to mention here that's really important is that you have to have the tools to measure what you're doing. Whether you've got a CV616 or you got an HX85, doesn't matter what machine you have. If you don't have the proper tools, and I mean, you have to have a profilometer, and I'm gonna go ahead and say it now because I've jumped the shark. I'm on the other side of the river now. You need to have both of these. You need to have the digital microscope. You need to have the profilometer. And I would highly recommend to anyone that you get the software from digital metrology. Because I'm going to say, how cool is this that I can see the crosshatch angle and my surface finish in one screen?
In one screen.
This is digital metrology. Mark Malberg, great friend, brilliant surface finish guy. This guy knows surface finish better than anybody. I'm a dummy novice from Mississippi, Tennessee hillbilly compared to Mr. Malberg and his knowledge. So this trace ball software is absolutely amazing. Look out, there's your RVK. All that in the blue is the RVK. You don't gotta be smart to figure it out. You just look at it. Oh, that's blue. That's RVK. Your RPK is in the red. It's color coded. How cool is that?
All I know is the last time you were on here and you brought the profilometer on here, how fast everything was moving through the chat of where do I get one of those? Where do I get one of those? Where do I get one of those? And now you bring new things in this time.
Yep.
You should see him with a PlayStation 5.
I'm not a gamer. My kids, they're gamers. This is my kind of game, right? This is my
PS5
digital toy.
right there.
Yeah, we actually.
But this thing's amazing. Go ahead. It's just an amazing tool. Oh, and Ed, right? This is something you guys have, right?
Yeah, we actually incorporate that on our hones. We buy Mark software and that piece from Mark and incorporated it on our hones, so you can actually see the crosshatch angle and the surface finish on the screen. Now, not the actual RVK, RPK, that sort of thing, but the camera itself.
Andy
we can
Rottler,
put
are
right
you
on our
listening?
screen. I hope so.
Andy.
Yep. That would be cool, wouldn't it?
Oh my God, yeah, it'd be amazing. Can you imagine being able to hone a customer's block and then be able to send out, because with the dial bore gauge, be able to connect it in there, say, here's your straightness, here's your roundness, or here's your dimensions really of your block. And then here's your surface finish, here's the crosshatch angle, all in a PDF.
Right.
I mean, if you're a machine shop that's doing work for other engine builders, that's a great tool to be able to have. That would be fantastic. And then even just as an engine builder, to be able to give your customer, say, hey, listen, you know what? You're running methanol. So here's what we've done to the surface finish of your engine because you're running methanol. And we recommend you use, this kind of oil and all these things for that reason, because we've done it this way. Or, you've got a compacted graphite block and you're running gasoline. Well, we've done it this way for this reason. And I just think, education and data, that's the deal. We're in a digital age and people are used to seeing data, right? People can get emails on their phone, open a PDF. So I think this kind of technology is what's really cool, is you can store all this here and you're not having, that's one thing I love about the Trace Boss, is that you can save all of your information on your laptop or computer. My phone, right, and Keith's is the same way. If you look at our photo reel on our phone, all it is profilometer pictures.
Yeah.
There's a lot of them.
Yep.
It's like, you're like, what are you into? I'm into profilometers, apparently, because everything I got is a screenshot of a Mitutoyo. Well, now I can capture it all here, and then I can go look it up. I can search it, I can share it, I can email it. It's so much better this way.
Yeah, the days of a fingernail or a penny or a dime in a cylinder wall, maybe once upon a time you could tell a rough finish from a smooth finish. But I absolutely promise you, you can't use either one of those methods on a plateau finish, because they're all going to feel the same. And your RVK could be 50 points difference and it's going to feel the same.
Oh, Ed, you're spot on, because even with the little coupons here on the pre-honed ones, before we actually ran them, all the ones that are the different plateaus, from the brush, the no brush, the 600, this, that, they all look the same to the naked eye.
Right.
Even with this, you can see a little bit of a difference, but not tons. But when you get the wear measurements, there's a huge difference. In fact, I should probably back up a little bit. One of the key learnings we've had so far, we're going to be here the rest of the week doing more testing, so we still got more learning to come on all of this, is that those rougher surfaces without the plateau, there's so much more adhesion going on, because what happens is you get these big giant peaks. They call them asperities in tribology, and those rings are hitting those big peaks, and then it will knock a big piece of debris off, and then you can see the wear scar from that debris, because the thing's just going back and forth, right? It's not going side to side, it's not rotating. So you'll see these big old long troughs that are cut in the cylinder just from those big peaks coming off during the break-in process because of how rough it is. So that's the key thing about why the profilometer is so important, because like I said, if you get it just really smooth, well, the ring will be happy because there's no big peaks to knock it into, but it's not going to last. But if I make it rough, now I'm going to have a bunch of wear that you don't really want. You have the valley, but you're going to get too much initial wear, and you could probably even get some maybe initial scoring of the cylinder that could ultimately make the life of the cylinder and the ring a whole lot shorter because of that abrasion and adhesion and all that bad things happening because it's too rough. I mean, it's anyone that knows me knows what I'm about to say. It's all about Goldilocks and the three bears. Not too smooth, not too rough, just right. And in your oil, it's the same thing. You don't want too much ZDP. You don't want too little ZDP. You want the right amount. It's balance is everything. And you can't find that balance if you don't know what you have, and you don't know what you have unless you have one of these. I'm going to shut up now.
Amen.
Well, I'm going to hit on one if I can. One of the things that we deal with here is, I know what our ring is. I know what it's made out of. I know what the coating is. I know what the coating hardness is. I know that part's consistent. The one thing, and this is why it's so important, and not to come off like we're profilometer salesmen, but one of the things that you deal with as an engine builder or a novice or a user, whatever your level is in this industry, the thing that you don't have control of is how hard is that cylinder? What's it made out of? The evolution of these is unbelievable. What they were from 15, 20 years ago to what they are today, to get the numbers we're talking about, are completely different honing processes. These guys, when you call up Dart and bought a block 10 years ago, you think that little M's the same as it is today? It's not even close. You bought a sleeve 15 years ago, that sleeve's not even close to what it was then as it is today. So we're constantly having to re-educate and retrain to get these numbers. We've been working with some of the teams. We're kind of getting there. They've got a really hard ductile iron sleeve, and we're really kind of getting their surface finishes sorted out. And now we come to find out, they're raising the hardness on those about 30 points. So start over. When you've got that profilometer, you can go in. And the one thing you don't want to do is don't wait till you're at size to check the numbers. You want to go in, and I see Ed nodding his head. He's going to agree. Go in there, put your stone in there you're going to use that you think you're going to use to bring it to size. Go in there, put some load on it, run it, get a few strokes, stop, check it. Look to see what the RVK numbers. I don't care about the other numbers at this point in time. But let's say I'm shooting for a finished RVK of, say, a 70 or an 80. Well, if I'm not sitting at size with at least 100 on there, there's no way I'm going to maintain that number and get a good plateau. So don't wait till you're done. You want to jump in there, throw your stone in there, put some load on it, run it, check that valley, see what you've got. Because if you wait, you wiped it all out. You killed it before you ever got there. And then as Lake talked about the scarring and the debris in the cylinder, most of what we're talking about right now is on iron-based cylinders. Well, hang on just one second. Here's this nifty thing, and I don't know if you guys can actually get a look in there. See kind of that plated look? That's Nickel. See that kind of a yellowy cast there? Mm-hmm. You want to destroy an engine? Hone Nickel too rough. You might get away with it with iron. You hone this too rough, those little pieces, those little chunks that are going to break off when you first fire that engine. We're talking nickel silicon carbide here, folks. This is hard stuff. It will chew an engine to pieces. So again, back to knowing what that surface finish is so critical. I see so many pieces come in here, rings that are scuffed up, pistons that are stuffed up, parts that are tore up. I had one in here the other day. It literally had little tiny pieces of iron in the ring line and stuck the rings in the piston simply because the bore surface was too rough when they first fired it. It all ended up in the ring lines.
Wow.
I'll get off my soapbox now.
Well, and the other thing, we preach a lot about surface finish and all, but the one thing that we haven't talked about, you guys go to inordinate lengths to make sure that your rings are round. And yet we haven't talked about cylinder roundness whatsoever. And that's one of the other things we've done at Rottler is we've tested a bunch of different hone heads trying to determine, is there a difference? And there is quite a difference. The old days of having a hone head that had 2 abrasives and a couple of brass wipers or guides, you'll call them, to put a dial bore gauge in there and check it, man, it looks great. But you cannot check roundness with a dial bore gauge. 2-point contact will never give you roundness. It will give you size, but it will not tell you true roundness. The only way to do that is with an incometer or a pat gauge, they call it. Very sophisticated, very expensive, $150,000, $180,000 for one of these instruments. So, not many people have them. And so what we tried to do at Rottler is we tested 2 stone, 4 stone, 6 stone, 8, 10, and 12. And the more stones you have in a hone head, the better the roundness is going to be. Now there's a law of diminishing returns, and we found that to be at about 6 stones. And so, there you go. There's perfect. There's the perfect graph there. That is a plot of a cylinder off of an incometer. And we're talking, that looks horrible, but you got to understand, you're talking 40 millionths of an inch. Every one of those little spacings is 40 millionths of an inch. So, very, very minute amount, but the 2 stone versus the 6 stone is about anywhere from about 1/10.5 to 2/10 better roundness than a 2 stone is. And so it does make a difference. And like I said, these guys go to extraordinary lengths to make sure that their rings are round. And then, we hone cylinders with all different sorts of honing tools and don't really make a round cylinder. We think they're round because we stick our dial bore gauge in there and check it and say, oh man, it's great. But you cannot check.
And also straightness too, Ed, right? Because
that's right. Yeah, absolutely.
That
you're right.
banana shape will still check.
Yes. It still checks dead straight.
Down.
Yes. Yeah, because you can't, when you have a banana like that, the dial bore gauge is reading, the two walls, and if they mirror each other, then you think you have a straight cylinder, and in reality you don't. The slinky.
That's my favorite one. I'm sorry, I can't help it.
I like that.
But wait, so Brad, since we're here at Southwest, I have one more cool picture I gotta share. Because we think our profilometers are really cool and we love them and they're really great, but they happen to have what's called a white light interferometer here. So it's 3D.
Wow.
Yeah.
Cool.
So what you're seeing here is the red is the high spots. That's the peaks. And then those valleys, that's the dark blue. So this is over here on the far left-hand side where the big red sides, that's the unrun part of that cylinder section that we've run. And then here, where you got the green kind of fading back towards that orange, that's the run part of the cylinder. And what's really cool is you can see right there at the very end of where the green stops, you can see that little bit of dip that gets a little more green. That's where the ring stops.
Oh, okay.
Because in tribology, what we call the Strybeck curve, because there's 3 stages of lubrication. There's full film, where you basically like a water skier is the best analogy I can come up with. So if think about when the boat's going 35 miles an hour and the skier's on 2 skis, he's up on top of the water, or she is. Then as the boat slows down in the no wake zone, the skier's still skiing, but they're sinking down in the water. But so they're not all the way in the water. That's boundary condition when the boat stopped, right? And the skier is just down in the water. So that's what changed there in this whole scenario. It was the speed of the boat. The load didn't change because the weight of the skier didn't change relative to the size of the skis. But the speed of the boat had to change because the load was the same and the viscosity, the water, stayed the same. So viscosity times speed divided by load gives you the Strybeck curve, and that's either full film, mixed film, or boundary. Full film is the skier going fast, 35 miles an hour. Mixed film is the skier in the no wake zone. Boundary is the boat stopped. So when that boat stops and the skier's in the water, that's where you're seeing that trough. That's the highest load, the lowest speed. In this case, the viscosity is the same because it's the oil heated to a temperature and controlled. And you can see that as the ring begins to accelerate away back towards mid-stroke, what do you see? You see those little peaks getting a little more oranger and oranger. Why? The oil film is getting thicker and thicker, just like a water skier coming up out of the water.
That's a great analogy. That really is for sure. Ed, there was one question from the chat that would apply to you, and the question was about stone versus diamond. Says stones seem to be making a comeback. What do you say?
I would say just the opposite, quite honestly.
Right.
We have a hard time with what we'll call standard abrasives, an aluminum oxide or silicon carbide abrasive, because of the nature of those. And especially with the harder Brinell blocks, they will tend to, in other words, you can use a certain grit, and it's not, and it's going to vary widely. We have found much more consistency out of what we call super abrasives, which is our diamonds for our base finish. Now, diamonds are a really hard particle, obviously, but they're not a sharp particle. They dull and they round, and so they plow and tear and fragment metal. And so we don't want to just do a diamond finish and leave it. You have to follow up with something else. And in this case, we use what we call CBN, cubic boron nitride. It's a very sharp particle, has a long wear life, and does a phenomenal job in those and plateauing with a 600 grit. It to me is the game changer that has allowed us to get to these extreme plateaus, as we call them.
You know, Ed, I think what Corey was going with is that people had the bad experience, if you will, with trying to finish with diamonds because of that. And what we're saying, Corey, is you still want to use diamonds to get to size, but then you're going to use a CBN to actually do the finishing to get it right. Whereas the old days, that's where the diamonds were getting the bad rap, is that people were trying to take them to size and finish with them, and you just couldn't because it's not the right kind of abrasive for finishing.
Yeah, you had all that torn and fragmented metal involved. And as you said, Lake, you know, you could see that if you were down there and you would test that. You'd have all this debris.
100% you can see it. You can even see it with this.
Yep.
Wow.
So that was a game changer.
Ed, Keith, Lake, as always, another just a highly educational seminar here. We appreciate it. Lake, in fact, I think we may even see you later on this week as well.
Yeah, I'll be here at Southwest all week, and me and Bill Alexander from Driven are going to do some talk on
oil analysis
on Friday. So for anybody who's watching, real quick plug here, because these guys at Southwest were kind enough to let me do this from here. You know, Southwest is a independent research lab. So anyone that wants to have testing done on pretty much anything, fuel, oil, piston rings, cylinder walls, whatever you want, these guys are here. So don't hesitate. If you're interested in tribology and you want to get some testing done, reach out to Dr. Peter Lee, Mike Munir, the guys here at Southwest Research. They're here to help anybody. It's not special just to us. These guys are here and can help support our industry. And they've done a lot of really cool stuff. They're super smart people. They're good people to have in your Rolodex for certain.
Thank you, Lake.
Registering on EPARTRADE is easy. To start, click on the Join for Free button on the homepage. First, search your company to see if it's already in our database. If you see your company on the list, click on it to select it. Then, choose Claim Company if you are one of the decision makers, an owner, marketing person, or main company contact. Or choose Join Company if you are an employee, and press Continue. If you couldn't find your company in our database, select Register a New Company. On the following page, fill out your name, email, phone number, job title, and choose a secure password. If you chose Register a New Company, you'll need to choose your business type. Select Supplier if you're looking to display products or services and connect with buyers. Choose Racing Business if you're looking to source new parts and connect with suppliers. Choose Race Team if you own or are a member of a professional race team. Then, enter your company name. Please provide a website, Facebook page, or LinkedIn if you have one, and choose to either claim or join the company. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Finally, click Register Now and your registration will be submitted for approval. An email will be sent to your inbox. Please confirm your email address and you will be approved shortly. Welcome to EPARTRADE.